Then we're going to learn about tangents and normal. You know how to do that from the last chapter, chapter 8. So let's review the procedure. The first step is to make y the subject, and then find the derivative, and then find the gradient, and then find the y value, and then point gradient form. Okay, so we're going to go through these steps. Let's try again. Okay, first step. Let's make y the subject. We're going to find the gradient of the tangent to the parabola. Okay, so you go x squared equal to 8y. We're going to make y the subject. Okay, so we'll do y equal to x squared over 8. That's the first step. Then you're going to find the derivative by differentiating. So we'll do dy over dx. That's equal to 2x over 8, which is x over 4. Yep. What's the next one? Find the gradient at that point. It tells you x equal to 4 by substituting the x value into the derivative. So therefore, m equal to 4 over 4 equals to 1. So the gradient is equal to 1. Okay? Alright. So it's pretty easy. You just have to find the gradient for this question. Okay, good. Let's move on. Okay. Hopefully you're ready. Okay, let's try the next one. We're going to find the equation of the normal to the parabola at the point negative 8, 16. Okay. Alright. Okay, let's start now. So what you do is you make y the subject again. X squared equal to 4y. Make y the subject. X squared over 4, like this. And then we're going to differentiate it. So dy over dx equal to 2x over 4. That equals to x over 2. Okay? And then what we do is to find the gradient of the normal, first find the gradient of the tangent by substituting the x value into the derivative. So we get negative 8 over 2. Okay, that doesn't look like an 8. Let's make it a bit bigger here. Okay, alright. So that becomes negative 4. Now notice that I write mt for gradient of the tangent. So therefore the gradient of normal will be the negative reciprocal of the gradient of the tangent. So therefore we get negative 1 over negative 4, which is a quarter. So we've got the gradient to be a quarter. And after we do that, we just use the formula point gradient form. Alright, get the idea how to find the equation of the normal. So we do y minus y1 equal to the gradient x minus negative 8. Yep. Alright, so we're almost done. So yeah, we can expand it. So write y minus 16 equal to a quarter x plus 8 times a quarter is 2. And then y equals to a quarter x plus 18. Right? That's it. That's the equation of normal. The equation of normal. But sometimes the question, or in the answer at the back of your textbook, they often write it in general form when there's a fraction. So if you write in general form, you write 4y equal to x plus 4 times 18. That will be 36. Double 36, 72. Alright, so like this. And then you do 0 equal to x minus 4y plus 72. Okay? General form. Okay, both will be correct. Any questions? Alright, so now we know how to find the equation of the normal, find the gradient of the tangent, and then we're going to look at the next bit, part B. Get down. Okay, continue. Alright, this normal meets the parabola again at P, find the coordinates of P. Now, to understand this, it's best if you draw a picture. All of the exercise in the textbook, you need to draw a picture so you can see what that means. So we have a parabola, x squared equal to 4y, right? This is x squared equal to 4y. What's the next bit? You say find the normal at the point negative 8, 16. So this is the point negative 8, 16. We found the normal. So normal, let's draw the normal, will look like this, right? It's perpendicular to the tangent. And then what that say is that the normal meets the parabola again at P. So meet the parabola again at P. So we want to find out what P is. That's what we're trying to do. So to do that, what we do is, since we got the equation of the normal, we just have to solve simultaneously with the equation of the parabola. And there you go, okay? Solve simultaneously. Alright, so just do that and you should be able to work out P. Have a try. That's the last example. Then we'll do a one-page summary, then we're done. We've already done the summary of locus, we'll do the summary of parabola, and that's all, okay? And then you start the exercise. Alright, how do we solve simultaneously? So what we do is we just substitute, right? So we're going to substitute, see this y is the subject, substitute this into this y here, right? I circle this y, get the idea. So you get x squared, the recording still, yep, that's good. X squared equal to 4 bracket a quarter x plus 18, like that. We're going to expand, so you get x plus 72, right? And you get a quadratic equation. Make sure you move all terms to the left side. And the number's pretty large, isn't it? It's a bit hard to factorize. So what you do is this. There's a clue. We already know what solution it has. What's one solution you already know? Well, you know you already intersect at this point, right? So one solution must be negative 8. So, right, we know one solution is negative 8. What's the other solution? We can get the other solution by think of the two roots of the quadratic, alpha and beta, right? So what does sum of the roots equal to? Negative 1 over 1, right? Which is 1, right? I'm showing you a different way of doing this. You can use the quadratic formula or use this nice little trick. Negative 8 plus beta is 1. What's beta equal to? 9. So now you cross that 9 without solving the quadratic equation. This is a very powerful technique that you should remember. That will save you a lot of time in the exam. Alternatively, you will be using a quadratic formula, which is very long. So you go x equal to 1 plus or minus. And then you will get somewhere at the end, minus 4 AC. And you will definitely give you negative 8 and 9, right? But it will take some time. But we're not going to do that, okay? I mean, you could do that, but I prefer you to use this method if you can. Because particularly in this question, they give you 1 point already. So you get the other one sort of for free, right? I get the idea how the method works. So we've got negative 9. We've got positive 9 here. Positive 9. So that's like a beta. So 9, because that's beta, right? And once you know P has the x value of 9, you sub it back into the original one. So to get y equal to a quarter x plus 18, replace x by 9. And then use your calculator. So you go a quarter 9 plus 18, so 0.25 times 9 plus 18, and that will be equal to 20.25. That's it, we've got P. P is 9, 20.25. 20.25. Alright, didn't have enough space. Knock this off. Let's write it clearly. 9, like this. Okay, got it? So we've got P. Any question? Alright, think about these techniques. Saves you a lot of time. One more page to go through, then we're done, which is the summary. Let's do the summary of the parabola. We've done the summary of locus already. Now we have to do the summary of the parabola. Alright, hopefully all done. All good? Next one. Summary of the locus of the parabola. So we know that vertex is at 0, 0. Focus is 0, A. Oh, that's a x squared equal to 4ay. Right? Directrix y equal to A. Definition of parabola. Let's use a green pen. The geometric definition is that any point, the set of points that's such that it's equidistant from the focus and the directrix. That's what definition. So definition will be PS equal to PB, right? So it's like distance, Equidistant from a point and a line. Equidistant. And whenever you see equidistant from a point and a line, that will be a parabola. Okay. All right, and what we also have axis symmetry, which I draw here. So the axis symmetry is x is 0. Yeah, you're right. Okay, whoops. All right, negative a. All right, negative a, 0, a. Yep, thank you. Okay, continue on. So axis symmetry is x equal to 0. We also have chord. So we're going to draw a line here. That's chord. Actually, it's not necessarily horizontal. So that's a chord, right? And then we'll also have a different color. Let me use, are there other color available? Not many available. All right, let's draw like this. So if I draw something through S, that's called a focal chord. Okay. So let's write down the definition. So what's a chord? A line joining any 2 points on the parabola. Right? That's what a chord is. A focal chord is simply a chord through the focus. Through the focus. Like that. And finally, maybe I'll use a yellow pen, see if you see it. Like that. Okay, good. So latus rectum is a focal chord that is parallel to the directrix. That's one way to see it. Or you can say it's perpendicular to axis. Right, get the idea? Alright, I think we've got everything. These are all the terminology you need to understand so that if the question mentions anything about it or asks you to find things about it, you know what to do. Okay? Alright, so summarize there. Alright, okay. So that's a basic idea of the parabola. Now we're going to look at parabola with vertical axis of symmetry. So we've got these things there. So we've got the focal length is A. So this one, the vertex is 0, 0. Let's use a blue pen. This is concave up. And negative is concave down. Yeah, that's all. And then you have these two, where the vertex is at HK. This is concave up, this is concave down. I guess you just draw a diagram. I don't know, something like this. Just remember, these are on the reference sheet. Reference on reference. Okay. On the other hand, the one sideway one is not on the reference, so you have to remember them. So we're going to write down focal length is A. Vertex also 0, 0 for these two. This is concave right, concave left, I guess. I don't know what names. So we just go sideway. These are sideway parabolas. Oops, like this. Unfortunately, these are not on reference sheet, so you need to remember them. Okay, and this vertex is HK. Okay, remember H first, and then the Y value second. All right, what else I want to... Yep. Yep, it's this one, right? This sideways, so if I draw it, it's going to be here. Vertex at 0, 0. Yeah. All right. And this one, the vertex, if I draw it, it's going to be here, somewhere here, I guess. HK. Yeah. All right, cool. All right. And also we need to know that sometimes they write parabola like this. You need to know how to transform them by completing square. Complete square. Right? So this one's a concave up parabola. Actually, maybe concave down. So you just go x squared minus 2x equal to negative 4y minus 16 and complete the square. So add 1 to both sides. This is the same example we did before anyway, so you can actually look up. Right? On the other hand, if it's a y1, you get y squared plus 2y equals to 4x plus 3. Again, you complete the square by adding 1 square on both sides. Oh, oops, sorry, I'm ahead of myself. Okay, all right, so minus 15. 15 here. Okay, like that. So you can see the similarity between them. Complete the square. So let's finish it off. So you just go x minus 1 square equal to negative 4y minus 14, and you have to take the negative 4 out, which you get 3.5 from memory. And then you get the vertex. Vertex is 1 comma negative 3.5, and you can figure out the focus and the directrix. Just see example. Yeah, I've got the example there. Which example was that? We did it together. That was exactly the same. Example 21. See example 21, page 14. All right, example 21. This one you go y plus 1 square equal to 4 bracket x plus 1. The vertex is 1, 1, and you can get the focus as well. Again, see example 24. Oh, thank you. That's good. All right, so that's a summary. One more thing I want to talk about. So this 1y squared, it's a sideway parabola, sideway. If it's a x squared, it's a concave up or concave down parabola. But if you got x squared and a y squared and some numbers like 4x plus minus 6y plus 1 equal to 0, that will be a circle. Okay? So note the difference. X squared, y squared is a circle. But if it's only got x squared, it's a concave up or down. Y squared is concave sideways, or this is a circle. All right, see the difference between them? All right, good. I think we've done everything, and we'll start a new topic next Monday. And you can start the exercise today. All right, good. Make sure you watch the video if you missed the lesson today. That's good. Now.